Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have a presentation from one of our students, Jialei, who has done his final project presentation about ROS Basics in 5 days, our course that we offer. And he's going to be showing us that project. He's going to be showing us this in a real robot that we have here. And well, without further ado, Jialei, hi, welcome.
Hi, everyone, and good morning.
Welcome. We're excited to see your presentation. So whenever you're ready to share your screen, you can get started and telling us a little bit about your project.
Okay, yeah, now we're good. Now sharing my screen now.
Mm-hmm.
So now you can see this is the camera in lab, and I've already connected.
Yes, we can see that.
Okay, so first of all I can show the whole process in this the real lab, and afterwards I will explain a little about my codes and how to implement all of this process.
Great.
Okay. Here we go. The first time for the robot is to rotate itself to face the wall, the nearest wall, near it, and try to approach the wall.
Mm-hmm.
And if there is a appropriate distance between the robot and the wall, it will rotate again, turn to left, and find a appropriate direction to start the wall following behavior.
Right.
And you can see in the terminal now, I have created a customized action.
Mm-hmm.
It will keep feedback the totally current distance that the robot has moved. You can see here, the robot has moved so far about 1.5 meters.
Right.
Yeah, and from our pre-knowledge, the total distance of this lab is about 6 meters. So I have set this if the current total distance reaches the 6 meters, the robot will stop on its own.
Mm-hmm.
Now you can see the robot is following the wall. We consider that the direction of the robot is not always straight. So you have to tweak itself during the whole process. If the distance is a little far away from the wall, it will turn a little right to approach it. And if it's too close, it will turn in the opposite direction to tweak the direction during the process.
Right.
Now we can see it has stopped because it has already finished one circle. And after all of the process, a list of all the poses the action has recorded will show in the terminal. But this pose is a little long, so we cannot see all of them.
Mm-hmm. Right. So that's, if you were to see those points, then that would be the trajectory of the robot, right?
Yeah, but this process has already been recorded in TXT file. We can check that later.
Oh, great.
And now I can show some codes of my project and
Yes, please.
tell you how it works. So basically, there are three main parts in this project. The first one is the wall following behavior, and before that, we have to firstly find the wall, help the robot find the wall to begin this wall following behavior. And during the process, we have to record the pose, including position and orientation of robots, and print it out at the end. So the main launch file is here. In this launch file, we launched the three parts. The first one is the action for recording odometry information. Second one is for for looking for the wall. And this one is is responsible for the wall following. In the scripts, I can see here there is a class find wall follow wall odometry record class. This will include all the process. Firstly, we subscribe to the topic scan. It will give us the data from laser to check whether the distance is appropriate. And we have to sleep for several seconds to wait for the topic is ready. Sometimes it will a little lag.
Right, okay.
Yeah. And we publish to this topic CMD well. It will send the command of velocity to tell the robot how to move. And this part, before all the wall following behavior, we set an action client to call a service that call action server, which we have created before. Now I can introduce something about this recording action. Firstly, we have to set a customized action, which is composed of 3 parts: the goal, result, and feedback. In our case, the goal has nothing specific because we can just tell the client to send a goal here. We don't have to send any specific information to get it started.
Right.
And during the process, the action will keep feeding back the current total space. Now, current total distance of robot. It will save in this variable current total, and after all of this, it will return a result about all the poses in one list. And this is the script for action. Firstly, we also subscribe to topic odometry. This will give us the information of odometry, including position and orientation. And sleep for 2 seconds to wait for it to be ready. We can just call this simple action server to create an action server. And when all of this is ready, the odometry information will be in this topic, and we can extract the corresponding information from it to save it in our local variable current pose.
Right.
And make this process open all the time. Firstly, we update the previous pose and extract the current pose, so we can at the same time have the previous one and the current one. So we can calculate the interval distance about current epoch and the current epoch, previous epoch and the current epoch. This will tell us whether the robot is still moving, because if the interval distance is nearly 0, we can consider that the robot has already stopped. And during this process, we calculate the interval distance and save it into this txt file. And
nice.
After we found out the interval distance is really small, nearly 0, we consider the robot has stopped and break out from this while iteration, and read the content in txt file to print it in the terminal. This is the action server. And the second part is another customized service for looking for wall. Before we make the robot follow the wall, we have to firstly find the wall. Yeah, this is the similar process
Yeah.
as the action. Firstly, we publish to scan topic and no, subscribe to topic scan
Mm-hmm.
and publish to CMD well. This is the part I create to escape a corner, but actually I'm not sure if it will always work.
Okay.
So I just skip this part. And the really important one is the from here. Firstly, we assume that the robot is at a random position near a wall.
Mm-hmm.
So we have to firstly find how the robot will rotate to the wall. The method is that we extract the distance information from laser data and find the minimum one. Find the minimum. That would be the direction directly against the wall, and we calculate the angle distance between this uh, wall direction and our front direction. This angle is the distance we have to rotate,
Mm-hmm.
and the rotational velocity will based on this degree. The higher this degree is, the uh, the faster
Oh, nice.
the robot will rotate. Because if there is a little, because if we have a constant speed,
Mm-hmm.
if the distance is pretty small, it may be
Overshooting.
over rotate. Yeah.
Right.
So we make the speed based on the distance. And after we make the robot rotate against the wall, we have to tweak the distance between robot and the wall. This part is shown here.
Mm-hmm.
Yeah.
So it
I
goes
have
back
set
and
the
follows.
sorry, yeah.
Right.
I set the profit distance as 0.2
Okay.
meters. And when it's get a profit distance, it will rotate to left again to make itself along with the wall.
Right.
This is the original initial position that robot starts to follow the wall.
Mm-hmm.
And this rotational part is similar with the previous one. The rotational speed will based on the distance in need to rotate.
Okay.
I won't go dive into that. And all of this, after all of this, terminal will show information that wall has already been found, and send back a service response to tell the main node that the wall has already found. You can start to follow the wall.
Mm-hmm.
And last but not least, here. Yeah, this is part to record the pose information. This is the looking for wall service.
Mm-hmm.
After all of this has already launched, we can begin our wall following. Firstly, we can check this variable wall found if it's set to be true, because this is based on the results from the service from wall follow one the wall looking results. So if it's set to be true, we can start to follow the wall. Firstly, we can give the robot a linear speed, and during the process, we have to firstly pay attention to whether it's already approaching a corner.
Mm-hmm.
And if the distance from the distance is less than 0.5 meters, we can say that the robot is approaching a corner and it's time to turn left to avoid the crash. Yeah. After this, during the straight line, it will keep tweaking the direction on its own. If it's getting too far from the wall, it will rotate a little right to get closer to the wall. vice versa. And based on the feedback from the action server, we can see how many distances we have already moved. If this distance reaches 6 meters, we can say that the robot has already finished the circle. So afterwards, we can send a shutdown signal to robot and make it stop. And that's basically all the process.
All right. Well, really nice, Jialei. Do you mind stop sharing your screen so we can I can ask you some questions with our faces here? Great, great. Oh, so congratulations, Jialei. Really nice project.
Thank you.
Really clear, and the comment you added everywhere just was really helpful to understand clearly what you were trying to do. So I really liked a couple of things that, let me see, that first of all, I really like that the odometry server outputs that list of atoms to a text file, and then you imprint that. That's nice too, because you know you can use that for a lot of things. You know, data of the for controllers. So it's really helpful. So I really like that, and I also really smooth movement and really simple. So that's also really nice, and your packages are also very descriptive, which is always appreciated. And
thank you.
I just had a couple of questions.
Please.
So you have a package, if I was being curious, called scan test. Could you tell us what that package is?
Oh,
I'm just
this
curious.
This one is just a scan, a test if the scan works. Because before I book this appointment, sometimes the scan laser will be will have a little problems. But afterwards, I found that it's actually not a problem of scan topic. It's something other stupid. I have already forgotten that, but this package is still living here.
So it was like you were doing some tests about the scan.
Yeah.
Nice. I mentioned it because I recently realized that the sun was coming in at some points during the day, and I think the sun hitting directly the walls and some parts of the lab actually affected that laser. So I just was wondering.
I didn't know that sunlight will affect the laser.
I don't know yet, so that's what I'm trying to figure out. I wouldn't believe so, but that was one of the explanations of another presentation. I was like, oh, let me see if that is the case. I just forgot about it. And then the other question I wanted to ask you was, you mentioned a method that you weren't sure that worked, that was like to skip corners or something, and I was just wondering what the logic of that was.
Okay. Would you mind I share the screen again?
No, you can just tell us what you were thinking and why you think it didn't work.
Okay. So basically, if this method is only feasible when the robot starts from a corner. It has nothing to do when it's approaching the corner during the process. So when the robot is starts from a corner, in theory, we can consider this situation that there will be the robot is in the dialogue at the corner, and if you stick the distance list of scan topic, you might find 2 minimum. But that's only theory.
Right.
Yeah, not only theory, but we cannot completely avoid this. So if there are 2 or more minimum with the same value, my algorithm will I have to say will fail to find the nearest wall.
The correct one. Okay.
Yeah, because before that, I consider the minimum as the direction of the direction of wall. But if we have two minimum, it's a little tricky.
I
So
understand.
yeah. So after this, I add the parts of to splitting the uh, range
Mm-hmm.
into four sectors, and check the uh, check four main directions: the front, the back, left, and right. Check all of this, and calculate and count if there and count how many minimums I have. Yeah, of course, I set a threshold. If the distance is less than this threshold, we consider it there is a minimum here, and calculate that how many minimums here.
Okay.
In theory, if there are two, yeah, I assume that there at most will be two of them when the robot is in corner.
Right.
But according to the process I've tested, sometimes it will give three or four. I actually don't know why.
Maybe,
So
but maybe because of the noise, something like that. Okay.
yeah,
All right.
yeah,
I understand. All right. Well, then I have pretty much, that's pretty much all the questions I had. So again, Jialei, congratulations for a really nice project.
thank you.
And that's it for us, you guys. So make sure to check out the courses that we are offering that Jialei took here to get a certificate. And we'll see you guys next time for our next presentations. Bye-bye.
Right. Thank you.